Hello, my name is Juan Camilo, and today we are going to develop the topic of clustering analysis in R. In this video, we are going to uh, deal with agglomerative methods by using R. So in order to begin, we have the R interface, as you can see in the screen. And as it is usual, we are going to put R name in the beginning. And we are going to use the following libraries. Remember that if you have not installed them yet, you can go to Tools, to Install Package, and the ones who have the English version, or in Spanish, Herramientas Instalar Paquetes. In my case, I've already installed all the libraries. So this is a package that does not exist. So let's keep these. Well, now we are going to use the data for rice in Nicaragua for this exercise that I'm going to share in the folder in this module. You can see this database. We are going to read it. Let's see the composition. Let's go to head. So we have the region, department, municipality, etc. We have the temperature, rainfall, the way it was sowed. We can use an str also that gives us information about the type of variables that this database contains. So we have 287 data times 47. So in this case, we are going to focus on the municipality called Ciuna. So to filter the data, we're going to use the deep layer library. You're going to see this in the latest modules, and we are going to use these colons because we want for this filter to belong to this library. So many times this is it's a good practice to use the two colons so that the function recognizes what library it belongs to. So the Ciuna data was filtered just with the data that belongs to Ciuna. So for this exercise, we are going to focus on 4 variables: yield, pH, organic material, and chemical composition. So we're going to download this data. Cationic information, and we're going to to select these columns. To select the columns, first we use comma, and then the vector that's called C and the variables that we want to use. So in order to apply this, we only have these 4 columns. Now what we're going to see is to scan, because if you see, each one of these variables have a different scale. So what we want to do is to standardize the information so that everything is in the same format. So we're going to scale, and then we are going to see how this database transforms. So by doing this, we've already standardized those 4 variables. What we're going to do now is to use the matrix that's called matrix dissimilitude. And remember that I mentioned that the distance between points, the most popular one, would be the Euclidean. However, it's not the only one. If we want to see more distances that are in this library, we write the question mark and dist. So let's go to help and we see the different methods that are available. So here you can see not only the Euclidean, we have the maximum Manhattan, Canberra, binary, and Minkowski. So there are different methods for the distances between the points. In this case, we're going to use the Euclidean. We're going to use the complete linkage, which is the distance between the groups. This will be the first. The first one will be the distance between points, and this one between groups. So we're going to use the complete method here. If you want to look for more distances, we can go to help once again. We can see complete, single, average, worthy. So are different methods to use. In this case, we are going to focus only in complete. Now let's write the dendrogram. I remember that these numbers down here, the ones that I'm signaling with the mouse, would be the index. So data 21 will be the data number 21. I can change it. In the meantime, I'm going to leave them just like they are, 21, etc. And these are the sets of groups. This is an agglomeration, meaning that it takes the data and starts to join them, depending on the distance. In R, we also have a function that belongs to the cluster library that's called Agnes. This function helps us to know how compact are the groups that we're working with. So when you run it, we'll be able to notice, okay, we're gonna write this HC2 first, and we use, and this gives us 0.847. This means that the closer we are to 1, that would be the optimal value that we'd have to choose. But in this case, we got 0.847. Now let's see how to apply a division method. The other one was agglomeration. Now this is a division, as we mentioned in the presentation. So this will be an HC method. And we're going to use this function called Diana. Something important at this point is to mention that computationally speaking, it's a lot harder to do the work that we did. To take an agglomeration from the base and up, because we have to calculate the distance between points and then groups. So it's easier to do it this way. Just doing a division, it's easier in terms of processing power required. Now we're going to see how homogeneous the data is. We get an 0.835. So if we compare both, the groups with the agglomeration method, it's more compact than the division. So let's see how this tree looks like now with this method. It's more focused to the left. And in R, we can also cut the tree. And we're going to define how many groups we want here. So with cut tree, we can cut the tree and form the groups. So in this case, I want to create 6 groups. And we want to see how they're going to be distributed. So these are the 6 groups. And we can also show the graph in the screen. So here they're showing us 3, but we want 6. And these are the 6 groups. We can perfectly see them properly divided. If we want to save this dendrogram, we can use export and save as, save the image. And if we want to see how they're distributed, remember that you have to use the table function. And by doing this, we know how each one of these groups are divided. Very well, that's all. Thank you very much.